welcome to the Mathematics News. This afternoon I want you to do two things. The first thing I want you to do is to find graphs. I'm interested in graphs. I want to talk a little bit about a particular graph in a minute, but I want you to look on YouTube, I want you to look on the internet, I want you to find graphs, as many different types of graphs as you can find. There are pie charts, bar charts, histograms, stem and leaf diagrams, line graphs, what else is there? Scatter diagrams, cumulative frequency graphs, as many as you can find. I want you to put them on our Padlet. Okay, I'm going to send a link on the homework page and you can put as many as you can on. So spend a little bit of time doing that. After that, I've sent you some work on my iMaths. I want you to complete as much as you can. We're going to carry on doing statistics. We're looking at scatter diagrams in particular. I'm going to show you how they work, remind you of how to use the averages, and then you guys have got a variety of things on the My iMaths stuff to do, including averages, scatter diagrams, not scatter diagrams, stem and leaf diagrams, things involving measures of location and spread, and to carry on with the standard deviation in the background. If you manage to get through everything else, the standard deviation is sort of extension work now. So good luck with that. Check out what happens next. Bats! Bats! More bats.
Go. Go.
Okay, so this afternoon there's some work on my iMaths and there's some other things I want you to do. The details are on your homework, but I want to talk a little bit about the difference between these two different things. Once you've got your data and you want to analyze them, especially if it's numeric data, quantitative data, discrete and continuous data, if you want to try and analyze it, it's helpful to calculate some actual statistics. And statistics are individual numbers that can represent like a whole group of data. And you're already familiar with some of these. Measures of location are individual numbers that give you an idea of the average of a population of data. So for example, we already know things like the mean, there's also the mode and the median. And these three averages are slightly different. The mean is where you add them all together and you divide by how many there are. So you can think of that as being the total of each individual number. Often X is used to represent each individual data point divided by how many there are. We always use N in statistics to represent how many things there are. The mode, of course, is another way of looking at it. The mean gives you what most people think of the average, but the mode is the most common item. And that could be a number, or it could be something that's qualitative as well. It could be the most common name or the most common item. But in general, the mode is the most common. The median, which is widely used, is also numeric, but it's going to be the thing in the middle, the item in the middle. So if you have a list of numbers and you put them in order from smallest to largest, it's going to be the number in the middle. It only really works if you put them in order, and so you can't just choose any old number if they're in a random order. You have to put them from smallest to largest. If it happens to be an even number of things, then you take the two which are in the middle, and then it's the mean of those two. So it's the number in the middle. And most people get mixed up between these three different things, but the mode has an O in it, and it's the most common, and there's O's there. The mean, I think most people know that that's the hardest one to actually calculate, so it's a bit mean if you have to calculate it. And the median has the number in the middle, and that's the one with an I in it there. So the median is the one number in the middle. Or if there's an even number of things, it's two numbers, and you take the average of those two, add them together and divide by 2. Measures of spread give you an idea of how spread out the population is, and we've talked about standard deviation already. So standard deviation is the classic measure of spread. That's the average distance away from the mean, and you can calculate that by using the square root of the individual numbers squared divided by how many there are, take away the mean squared. So that's the individual numbers added together and divided by how many there are, but you square it. Okay, my pen's running out. That's the standard deviation formula. Often we use the minor sigma for that. This larger sigma, as we've talked about, is adding a whole load of things together. Here you have to square them first, then you add them together. This is just adding numbers together divided by n and then squaring them at the end. So standard deviation is a measure of spread. But there's other ones too. There is, of course, just the range. Very, very simple. The range is just the highest number, take away the lowest number. And that gives you a very simple way of working out how spread out the numbers are. The standard deviation is more sophisticated because it's the average distance away from the mean, which actually gives you an idea of how spread out they are. The range, if you might have one number which is crazily high, the range can look bigger than, and sort of gives you a bad idea of what the data is all about. Sometimes people use something called the interquartile range. And the interquartile range is a slightly more sophisticated way of looking at it than the range. The interquartile range looks at the middle half of the data. The middle half of the data sort of ignores the lowest numbers and the highest numbers and focuses on the average half of the data. And it's another way of looking at how spread out the data is, but it ignores all the freaky numbers. If there's a really big number or there's a really small number, the interquartile range doesn't have to use that. It's just focusing on the middle data. And we calculate that by looking at the difference between what we call Q3 and Q1. Q2 is the median, and Q3 is the median of the top half of the data, and Q1 is the median of the lower half of the data. Sometimes this is called the upper quartile and the lower quartile. This one is like a quarter of the way into the data from the beginning, from lowest to highest, and this one is 3/4 of the way in. And if you want to find these two, you find the median first, and then afterwards you look at the median of the top half and the bottom half. Now it depends when you do the median whether you start with an even number or an odd number, but I'll show you an example now. I'm now going to show you a stem and leaf diagram which gives you an idea of one way of displaying data. It's a very quick and easy and simple way of displaying data. So a stem and leaf diagram is a bit like a bar chart really, but it's composed of numbers. Instead of having like rectangles, you have actual numbers to represent things. I want you to imagine that there's a test. So you guys have a test, and then we take all the scores and we put them into a stem and leaf diagram. So the scores might be, for example, let's have 22, 27, 29, 34, 35, 38, 39, 40, 40, 41, 43, obviously this is bigger than our class, 48, 54, 56, 57. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here there are 15 numbers. I'm going to put these into a stem and leaf diagram by first of all forming a stem. So this is going to be the beginning of each of these numbers. And then the leaves are the end parts of the numbers. So 22 looks like that. And then 27 and 29. 34 goes in this place here. 34, then 35, 38 and 39. And then I've got 40, 40, 41, 43, 48, 54, 56 and 57. So you can see it looks a bit like a bar chart with the bars going this way. But what's nice about this is that we can use it to find the median quite quickly. Everything's in order. If it wasn't in order, you'd have to put it in order first. But to make sure this is a proper stem and leaf diagram, you have to have a key. So I'm going to do this. I'm going to define my stem and leaf diagram where we have 3/4, like that number there. That means 34 marks for this particular test. If you don't have a key like this, people don't necessarily know what the stem and leaf diagram is representing. So here that means 34 marks. This one means 40, that one means 48. It doesn't just mean 8, it's attached to the stem. So the leaves and the stem together make up the individual data points of this particular graph. Now, if I want to find the median, I need the number in the middle, and you have to work your way towards the middle. So that's the smallest number, and then the largest, smallest, largest, smallest, largest, smallest, largest. I can keep on going like this until I find the number in the middle, which is this one. So the median, or the number in the middle, is 40. If I want to find the lower quartile, that's the median of the numbers at the top. These sort of lowest numbers will have the lowest quartile as the median of just those ones. So lowest, highest, lowest, highest, lowest, highest, there we go. That's the lower quartile, sometimes called Q1, which is 34. And of the top numbers here, I've got lowest, highest, lowest, highest, lowest, highest, that 8 there, which is 48. So Q3 is 48. And from that, I can find the interquartile range. The interquartile range, in this case, would be that, take away that, which is 14. So that really is looking at how far apart this number is and this number is. It ignores the very big numbers, it ignores the very small numbers. And it gives you an idea of how spread out the numbers are. They're quite spread out, considering this was a test out of 60, say. And then you could compare two different groups. The most powerful thing about stem and leaf diagrams and these statistics and measures of spread is when you start to compare two different groups. So imagine I had another group who did the same test and their interquartile range came out to be, let's say their interquartile range was 3. It makes a huge difference if you compare the two different groups. That means this group, they were all over the place. They had lots of different test scores. Some were high, some were low. There's a big difference between the middle half of the data. But this group, the alternative group, there was not much variation. The data was very close together. They were only 3 apart in the middle half of the data. So it gives you more insight into data. You also can look at the median and check to see what the difference is between the medians. So here, if the median came out to be median of Q2, that's sometimes called Q2. The median for this separate group, say if it was, I don't know, 10, then that means their medians, if you compare them, are hugely different as well. That means these guys scored more, these guys scored less on average, and these guys were more consistently awful, and these guys were more varied, but on average, they had higher scores. So when you start to analyze data like this, it gives you a nice way of looking at the difference between two different groups. And that's where statistics becomes quite powerful. It gives you an insight into the information you presented. Instead of just a big list of numbers, you have something that actually gives you information about the differences between groups. And that's what statistics is amazing for.
Go. Go.
So from the Mathematics News Desk, me and Mr. Broccoli wish you good afternoon.